A newly discovered comet called C/2026 A1 MAPS is heading toward an extremely close encounter with the Sun on April 4th, 2026. Astronomers say it will pass deep inside the solar corona, a region where many sun-grazing comets break apart. Early observations suggest it could brighten significantly, but its survival remains uncertain. If it holds together, the comet may briefly become visible after perihelion. Scientists are now tracking its trajectory and behavior as the encounter approaches. In this video, we will break down what this comet is, what could happen on April 4th, and whether it might become visible from Earth. Let's get started. C/2026 A1 MAPS was first identified in January 2026 using telescopes located in Chile's Atacama Desert. At the time, the object appeared extremely faint with a magnitude near plus 7.8. It was not visually impressive, but its orbital path quickly drew attention. Calculations showed that the comet was heading toward a very close solar passage, placing it among a class known as sun-grazing comets. Sun-grazers follow trajectories that bring them within just a few solar radii of the Sun. This region is dominated by intense radiation, extreme temperatures, and strong gravitational forces. As comets approach this environment, their ices rapidly sublimate, releasing gas and dust that form the coma and tail. The closer they get, the more dramatic this activity becomes. Further orbital analysis indicated that C/2026 A1 MAPS belongs to the Comet group of sun-grazing comets. These objects are believed to be fragments of a much larger parent comet that broke apart centuries ago. The fragments continue to travel along similar orbits, occasionally producing bright comets when larger pieces survive their solar passage. Historical members of this group include the Great Comets of 1843 and 1882, as well as Comet Ikiyasaki in 1965. One important aspect of this discovery is timing. Many Comet comets are detected only shortly before reaching perihelion, often by solar observatories. In contrast, C/2026 A1 MAPS was discovered months in advance. This allows astronomers to monitor its brightness evolution, refine its orbital parameters, and estimate how it may behave during its closest approach. Current predictions place the comet's perihelion distance at about 1.18 solar radii from the Sun's center. This translates to roughly 160,000 kilometers above the Sun's visible surface. At that distance, the comet will effectively travel through the solar corona. Temperatures in this region reach millions of degrees, and the environment contains energetic particles that can alter the structure of comet nuclei. As the comet approaches, increased heating will cause rapid sublimation. Dust production may intensify, potentially increasing brightness. At the same time, structural stress may build within the nucleus. Observations leading up to perihelion are therefore focused on tracking any signs of fragmentation, changes in brightness, or unusual activity. Because the comet was detected early, astronomers can compare its behavior over time. This helps determine whether it is maintaining structural integrity or showing signs of instability. These measurements provide clues about its size, composition, and internal strength. The scientific interest in C/2026 A1 MAPS comes from how sun-grazing comets respond to extreme solar heating. As a comet approaches the Sun, its surface warms rapidly. Ice transitions directly into gas, carrying dust particles away from the nucleus. This process increases activity and can make the comet brighter. However, heating is not uniform. The surface facing the Sun warms much faster than the interior. This creates thermal stress, which can fracture the nucleus. At the same time, gravitational tidal forces from the Sun can pull on weaker regions. These combined effects often lead to fragmentation. Observing this process in real time helps scientists understand the internal structure of comet nuclei. If a comet breaks apart, the pattern of fragments can reveal whether the nucleus was porous, layered, or loosely bound. If it remains intact, the rate of dust production can provide clues about composition and surface properties. Another factor affecting brightness is forward scattering. When sunlight passes through dust particles in a comet's tail at certain angles, it can scatter toward Earth, increasing apparent brightness. This effect is especially noticeable for sun grazers positioned close to the sun in the sky. In some historical cases, this has briefly made comets visible even in daylight. Astronomers are also interested in how Croyt's fragments evolve over time. Since these comets originate from a shared parent body, each observation helps refine models of fragment size, distribution, and survival probability. Comparing different members of the group helps determine why some survive while others disintegrate. Gas emission measurements are another focus. As heating increases, volatile materials are released. By analyzing spectral signatures, scientists can identify components such as water vapor, carbon compounds, and dust composition. These measurements improve understanding of primitive solar system material preserved in comet nuclei. Even if the comet does not become bright, the data collected during this solar passage remain valuable. Sun grazers provide rare opportunities to observe comet material under extreme conditions. Observations of activity levels, tail development, and structural behavior contribute to broader studies of comet evolution. Because the comet was detected, early scientists can track changes leading up to perihelion. This allows comparison between pre-perihelion and post-perihelion activity. Such comparisons help determine how much material is lost and whether the nucleus remains intact after solar heating. As the comet moves closer to the sun, observation methods will shift. Ground-based telescopes can track it only while it remains sufficiently separated from the sun in the sky. As the angular distance decreases, glare makes observation difficult. At that stage, space-based solar observatories become essential. The Solar and Heliospheric Observatory, known as SOHO, is expected to capture the comet during its closest approach. SOHO uses coronagraph instruments that block the sun's bright disk, allowing faint objects nearby to be observed. Many sun-grazing comets have been studied using this technique. During the solar passage, astronomers will watch for signs of fragmentation, brightness changes, and tail evolution. If the nucleus begins to break apart, images may show multiple fragments separating. This would indicate structural disruption. Alternatively, a stable brightening object would suggest that the nucleus remained intact. The period following perihelion will determine whether the comet becomes observable from Earth. Surviving sungrazers often brighten as they move away from the sun. However, visibility depends on geometry, including the comet's position relative to the sun and horizon. The comet approaches from the southern celestial hemisphere. This may favor observers at lower latitudes. For northern observers, the comet may remain low near the horizon, making observation difficult. Twilight conditions will further limit viewing opportunities. The potential viewing window may be short. Sun-grazing comets often fade quickly after their closest approach. Dust disperses, activity decreases, and brightness drops. This means any visible phase could last only a few days. Regardless of visibility, observations during this event will improve models of comet survival and fragmentation. These data help refine predictions for future sungrazers. Understanding brightness behavior also improves estimates of visibility for newly discovered comets. This event also illustrates how dynamic the solar system remains. New comets continue to appear, and their behavior can vary widely. Some disintegrate without notice, while others briefly become prominent sky objects. Observations of C/2026 A1 maps will add to this growing record. As April 4th approaches, astronomers will continue monitoring brightness, tail formation, and structural changes. These observations will determine how the comet responds to its solar passage and whether it remains detectable afterward. This newly discovered Comet C/2026 A1 maps is about to pass extremely close to the sun, entering one of the harshest environments in the solar system. Its behavior during this encounter will determine whether it briefly appears in our skies or fades near the sun. Either way, the observations around April 4th will provide a rare look at how sun-grazing comets evolve. I'd love to hear what you think about this, so drop a comment below. If you enjoyed our conversation today, please share this video and subscribe to help the channel grow. Every bit of support counts.